My name is Cliff Sadof, and I'm from Purdue University, and I'm here joined with my colleagues Robin Usborne of the University of Michigan State and Amy Stone of Ohio State University and Elizabeth Barnes of Purdue University. And I will be giving today's webinar on recognizing and reporting exotic forest insects. This is the third webinar of the Spring EAB University webinar series, and the next one will be given by Mark Whitmore next week, March 8th at 11 o'clock, and Mark will be talking about hemlock woolly adelgid and biological control efforts. This webinar will be recorded, and it will be available as a YouTube video from the Emerald Ash Borer University website. CEU credits are available. Just contact Amy Stone at stone.91@OSU for more information. Okay, so with that, I'm going to get started. And today, in honor of National Invasive Species Awareness Week, we are going to focus on recognizing and reporting forest pest insects. And if this all goes well, I'll be able to move forward. Okay. All right, so an overview. The main reason that we're focusing on forest, reporting, or I guess the main purpose of today's talk is to demonstrate, give you some ideas of some tools that are available that citizens can use to report exotic pests. And the reason we do this is that, as many of you know, in many states, there may be a handful, maybe if you're lucky, maybe a dozen inspectors that can go out and look for exotic invasives. But when you think about the number of people actually working in the green industry or working in landscapes, I know in Indiana there may be 40,000 people who are actually involved in this sort of stuff. We have a lot of watchful eyes that are out there. So the goal of this citizen outreach and citizen forest pest reporting is to get some of these eyes out in the landscape so that they can report things that look suspicious. And most recently, there's been a couple of mobile apps that have been developed to allow citizens to take photos of suspicious looking creatures, send them to state experts like people like myself who can confirm them, and then send out a team of actual inspectors to determine whether or not the pest is there. So today I'm going to talk about 5 pests: the Asian longhorned beetle, emerald ash borer, spotted lanternfly, hemlock woolly adelgid, and thousand cankers disease. Okay, so now we have a lot of apps that are available. Some of these things I've talked about in the past from Purdue University include the tree doctor, perennial doctor, annual doctor, on Turf Doctor, and this can allow you to identify hundreds of plant disorders and get recommendations on how to manage them. But what I want to focus today on is this app on the lower left side of the square called the GLEN app, which stands for the Great Lakes Early Detection Network. And what this allows people to do is once you sign in, it allows you to report information to experts like myself via this EDMAP system, which comes out, which is a GIS, sort of a geographical information system that is managed by the folks at Bugwood. Charles Bargeron is the lead programmer. And this information is shared so that we can get locations of where these reports are, and then once they're confirmed, they can be uploaded onto an official map. So when you open up the app, there's a lot of things that you can do. Probably the first thing, the way I like to run this thing through is that you would get on the app and select a species category to report the kind of organism you saw. So let's say, for example, you are walking in the woods and you notice a suspicious looking maple tree that you think might in fact have Asian longhorned beetle. So you would select the insect, you would click on the species categories, select the insect button, and then choose Asian longhorn beetle. Now, what's interesting about this insect set of categories, there's a bunch of dots on the right-hand side with the letter R, excuse me, with the letter I. And if you touch that letter I, you'll start getting photos of images that you could use to confirm your identification. So here you see a picture by Joe Boggs of an Asian longhorn beetle that is on his hand with a penny, and then you can see some of the oviposition holes and some of the exit holes taken by the photo taken by Dennis Haugen. So let's say, so once you decide that you find things, you can actually what it does is, you see on the bottom part of the screen, it actually records your location, exactly where you are, and you can add a photo, or you can take a photo, and that photo will be used and will be sent to the identifier. So here, let's say, for example, you take a photo of some of these pock marks, which are some of the telltale signs of Asian longhorn beetle on the maple. It'll then take your location, and this little dot right here is exactly where I'm sitting, where all this magic is happening at this point in time, and it would record where I am. So theoretically, you can imagine you'd be walking in the woods, or you'd be walking in some sort of landscape. You would find something you suspected to be Asian longhorn beetle. You take a photo. You would then send the picture of the damage as well as the picture of the location. That will allow an inspector to easily go there and find and inspect things. Other information that you could report would be some information about the host, saying that it was a forest of hardwoods and softwoods. Maybe it was a fence row. Maybe there was some discoloration that you noticed on the trunk, and you can give some estimate of the percentage of the trees that are indeed damaged. Then once you do that, you have to click the save button on the bottom of the screen, and then that would save your report. And then you would click back on, and you would notice that there is something called an upload queue that would allow you to upload the reports. You can then click that upload queue, and you would see here that it gives you the option to report a positive report for Anaplophora glabripennis, which is the fancy name for the Asian longhorn beetle. And then you would click on the action button and submit the report, and then it would go to the experts in the state. Okay, and then so what happens to me is that I would eventually get an email from somebody from GLEN's that would tell me that somebody has found something. At least if you're in the state of Indiana, that they found something, and I would get it. These apps are available through through the App Store. You just or the Google Play Store. You just search for GLEDNS, the GLEN's system, or Great Lakes Early Detection Network, or EdMaps, and you'll be able to find these things. So you can actually Google apps at Bugwood, and you can get a whole list for which apps are available in your state. Okay, so now that we have these groups of volunteers who are out there in the field willing to report things as they see them, we now have a tool to be able to see them. So what I wanted to focus the rest of today's talk on is how to identify some of these bad actors. And one of the baddest actors that we have out there is the Asian longhorn beetle. I adapted this presentation from some slides that Amy Stone and Joe Boggs of Ohio State had prepared, and that we use these slides in a program which we call the Forest Pest Outreach Survey Project that we have here in Indiana that we conduct each summer. So Asian longhorn. So I started by saying why Asian longhorn beetle is important. It's a real big problem because it's a major pest of maple. It came into the United States because there were many poplar shelter belts that were planted in China, and as these things were dying, unfortunately, some of these these trees were used in as solid wood packing material, allowing the beetle to hitch a ride into North America. So ALB feeds on a lot of different kinds of plants, but the preferred hosts are maples, okay, horse chestnut, elms, and willows. But typically, you know, most of the reports that we find in the United States are indeed maples. And there are other hosts like birch, poplar, and even ash, if they can find them, if there are any left. But these things these are used when there is nothing else for the insect to feed on. Okay, so this Asian longhorn beetle has a 1 to 2 year life cycle, and it will starts, you know, what happens is that the adults will emerge from the trees. They will then dig oviposition holes, and where they'll lay the eggs. The eggs will hatch into a larvae. They grow bigger and bigger, which will then bore into the wood, and then they'll pupate and come out again. Young larvae actually just have a really interesting life cycle, is in that only the young larvae, the early stage larvae, feed on the phloem. So this is a maple tree that we were peeling, and you know, in the springtime, and if you would touch it, you would notice that it's that tissue feels kind of wet. Okay, so this is, and so the tissue that you see that's exposed is actually the phloem, and the brown spots actually are places where there is a Asian longhorn beetle larva feeding. And here you see one close up that's feeding, causing this localized necrosis or tissue death. All right. So after it feeds for about 2 weeks or so, it molts, and then it'll start boring into the heartwood of the tree. These things can get quite large. You can see this is actually almost 2 inches long. You can imagine that can cause quite the sizable hole inside the trunk of a tree. So what happens is that, you know, in time, as you see this beetle on this disc over here, you can see the size of the holes that are being bored into the tree, and you can imagine that once a tree has lots of holes inside of it, as on the left-hand side, you see this picture of a branch that is totally hollowed out by the Asian longhorn beetle. So you can imagine one decent ice storm in the wintertime with some snow and wind on top of that will cause these things to break. And, you know, I know there's a nor'easter headed up on the East Coast right now. So, you know, any tree that was pretty much hollowed out by the Asian longhorn beetle would probably snap quite readily. So what do you look for, you know, when you're out there? If you see perfectly round holes a little bit smaller than a dime, that would pique your interest. Look for oviposition scars, as you see the one with a penny. You might see some frass, these shavings. You might see woodpecker holes, as you do on the top. And then, you know, if you're lucky, you might see the beetle or the larvae. One of the things that really sort of shocked me the first time I saw this was how these trees show almost no obvious signs of canopy decline when they're heavily infested. So I went down to Bethel, Ohio, just fully used to work with emerald ash borer, expecting to see a tree that was half dead, and these trees were heavily infested. I had it look several times to actually find it. I got close up to the tree, and this canopy looks really healthy. But when I looked really close up, what I saw these oviposition pits on there, and you know, that tree was actually pretty hollowed out. So that to me is the scary thing. I just can imagine these large silver maples in Midwestern towns all hollowed out, that are going to come crashing down on somebody's house and harm somebody. So close inspection is necessary. These exit holes are great diagnostic tools. You can tell by their size, but this trick here that is a trick that Joe Boggs likes to show when he gives his talk about these things, is that if you can take a pencil and stick it deep into the hole, that's going to be caused by emerald ash borer. I mean, excuse me, by Asian longhorn beetle, and nothing else is really going to do that. Other things that you might see might be the adult will be feeding on twigs. They may also feed on the petiole. And you can see that they actually do what I like to think of as reverse skeletonization. They feed on the veins of the leaf and leave the leaf tissue alone. So these are the kinds of things. This is I think is the silver maple that is showing some damage. Okay. So on to the next bug is the emerald ash borer, which is the namesake for Emerald Ash Borer University. And they're in Indiana. They're a real big problem. But you know there are something along the lines of 8 billion ash trees in North America, and they threaten extinction of native ash trees. They tend to feed on white ash. Uh, the vast majority of the white ash are indeed killed. The green ash and the white ash and the black ash are highly susceptible. There are few, if any, survivors once those are attacked. Blue ash, on the other hand, is somewhat resistant, but it is also attacked, and it's definitely a viable host for the emerald ash borer, and it's kind of distinguished by these quirky wings on the stem. So EAB is a death sentence, killing nearly every untreated ash tree, and this is a forest in Michigan where all the ash trees have been slaughtered by the emerald ash borer. And you can tell they're ash trees because they are dead. So how does it kill the tree? So this is very different from the Asian longhorn beetle. The larvae feed in the cambium and phloem their whole life. So you remember I showed you that picture of the Asian longhorn beetle. You saw the Asian longhorn beetle larvae feeding in the phloem, and then they move down into the xylem, into the sapwood, and then deep into the heartwood. These guys are primarily feeding just on the cambium phloem their whole life. So that means that they will actually kill. They will actually disrupt the ability of the tree to lay on new bark, and then as they get bigger and they score the sapwood, the actually functional xylem, which in ash trees is only a single layer of xylem, single row of xylem, that will actually prevent a tree from being able to take up water and nutrients, and will cause it just to dry out, die. So their life cycle right now, it is March. They are in the J-shaped stage, okay, underneath the bark. They will start pupating in April at some point in time, and then the adults will crawl out, leaving their characteristic D-shaped exit hole. In May, the adults will mate. Females will feed on leaves to get nutrition so that they could lay their eggs, and the eggs are laid on the bark in July. The eggs then hatch into larvae, which will bore beneath the bark from July through September, leaving classic zigzag galleries that you could see underneath the bark when you peel it. So one of the early signs that you would be as an early detector to see would be to look for thinning of the leaves in the upper canopy. It starts at the top and eventually it gets worse, as you see on the right. Then this time of year, probably right now, is I would be looking for woodpecker feeding. And you know, if you see, you know, when emerald ash borer is really going, you'll look at these trees will have most of the bark flecked off. You know, these woodpeckers are tapping on the trees in search of hollow, mushy spots filled with larvae that they can pluck out and remove. And when things get really bad, they will turn an entire bark blonde. We call it blonding and such, and you can just see where the woodpeckers have been active. Here's another photo. Other things you could see is that, you know, as I told you, it kills the emerald ash borer kills the part of the tree that lays on new bark. So when the healthy part of the tree is expanding, it's pulling out the other side of the tree and causing it to split, kind of like, you know, like eating too much at the all-you-can-eat buffet. You know, and you start gapping your shirt. Basically, it just sort of gaps the trunk of the tree, and it'll split. Then you can see the zigzag galleries, which are telltale. Nothing else really does that. And then, of course, you see the D-shaped exit holes. And finally, the last gasp of the tree prior to its dying is the production of epicormic shoots, which is just basically a last gasp just to produce tissue in the hopes that maybe one might produce a seed or something that will allow the tree to survive. But so when you see a tree like this, these trees are essentially dead. One of the things you need to know as a identifier is how to identify an ash tree. Ash trees have got compound leaves. They also have got single leaf samaras. They have single leaf seed. They have single. They have seeds you see on the right that are single wings, which are called samaras. So you can see that an ash leaf is compound, whereas a maple on the bottom is a single, is not a compound. It's called a simple leaf. So ash trees have compound leaves. They've also got opposite branching, as you can see on the left, as opposed to alternate branching, which is you see on the right. And that means that you can imagine if you stand in front of, and you're standing up, your arms are opposite each other, but your arm and your leg are alternate each other. So think of that sort of pattern. And here we see a branch with all the symptoms, all the diagnostic tools. We see the opposite branching, and we see the compound leaves just beginning to emerge in the spring. Other things you can take a look at are they have diamond-shaped patterns. You can see the oar-shaped seeds, the single samaras we see here in the center. Green ash can be smooth, and when it's young, and then the bark is still somewhat diamond-shaped, but not quite as distinct as, say, in the white ash. Blue ash is even less distinct, but they do have opposite branching, and they do have single samaras, but the blue ash has the winged shoots. Okay, so it's really important to identify these things. I have to tell you a story. I did get a phone call a couple of years ago from somebody who was concerned about thousand cankers disease because they had black walnuts that they thought were dying, but it turned out that they had black walnuts mixed in with a stand of ash, and the trees which they thought were black walnuts were actually ash that were killed by the emerald ash borer. So identifying the tree is really, really important in order to making a diagnosis. And ash trees are fairly simple to identify with that opposite branching, because nothing really looks an awful lot like it when you have the opposite branching taken into account. All right, I'm going to move on to something which is kind of new. It's called the spotted lanternfly. This is new because it was detected in Pennsylvania in 2014, and it's all the rage right now amongst the invasive bug people because we unfortunately think it might be on the move. Came here from Southeast Asia, detected in Pennsylvania. It was probably arrived on quarried stone, and it the problem is that it's not on stone because this insect loves to lay its egg on smooth surfaces. It lays its eggs on lots of different kinds of things, especially likes tree of heaven, but it lays its eggs on lots of different types of surfaces, and that's how it got here on stone quarry. There are about on quarried stone. There are about 70 different hosts. Plants. Tree of heaven is supposedly a host that they have to feed on, but that is still a matter for debate. We still don't know that much about the biology of this insect. They love fruit trees, grapes in particular, peaches and apples. For those beer lovers here and people who are growing their own hops, they also like to feed on hops. And unfortunately, they like some of our more precious woods like oak, black walnut, poplar, and pine. As I said, they lay their egg masses on everything. As a matter of fact, last year, some Christmas trees that were grown in a plantation in Pennsylvania were shipped into New Jersey, and they found egg masses on the stems. So this, to me, is probably the most scary part, since I know that Pennsylvania is a net exporter of Christmas trees. It's a great way to ship these insects on Christmas trees. So, if you are in a situation where you are inspecting trees, Christmas trees coming from other states, you really want to make sure that you keep those spotted lanternfly on your radar. As I said, they can move on stone, and also, if somebody's going camping in an area where there's an outbreak, they could lay their eggs on the wheel wells of campers or any other vehicle you have, and then that's a great way for it to move these things. It's kind of like the same, like the gypsy moth analogy. One of the characteristics you can see here is that they're very distinctive. Nothing at all looks like it. They've got spotted wings. Okay, their underwings are bright red with black dots. The nymphs start out black and white with white dots, and then they move into red and black with white dots. I mean, these are, it's a shame they're so invasive. They're quite beautiful insects. This life history that we have over here uh, was just sort of explains what they do. They lay the eggs on a smooth bark in the fall. The nymphs will hatch from the eggs in late April to early May. Then later they'll develop the red spots, and the adults will appear in July, and they can develop wings, and that's where they'll fly around. So if you see something, this is the only thing that really looks like it. Here's another scary thought. Here we see this is a post that was one of the staff at Penn State took a picture of a post in a vineyard holding up grapes, and you can see how they laid tons of eggs on this, okay, on this post. And then that's a really scary thought. Here we see you can see what the egg mass looks close up on the bark of an ailanthus tree. You can imagine if that post was a metal gray, it'd be really hard to see to see them. Here we see all the life stages of the spotted lanternfly over here, and there you see all the different life stages all the way up to the adult. This is the scary thought for the grape growers. It is you can see that the grapes are all sticky. These spotted lanternflies are sucking insects. They're in the family Fulgoridae, which means that they suck a lot of sap. And the glistening color that you see on the leaf of these grapes, as well as the glistening color that you see on the grapes themselves, is not dew from early morning. It's honeydew from liquid excrement of the spotted lanternfly. So they're like just peeing like little racehorses, so to speak, all over the grapes. Not very, very pleasant. It's kind of filled. It's this liquid excrement, which we call honeydew, is quite sweet. It's filled with sugar and some proteins, which is a great substrate for mold, which can cause this thing to turn black. This is, I took this picture because this is a photo. Actually, there was an article in today's Washington Post where they use this photo to show the different life stages on a black walnut, and you can see the lower branches of the black walnut have a little black tinge on them because that's where the sooty mold is starting to grow, and you can see these lovely colored, exotic-looking lanternflies all over the plant. So I think that if you have something like this would be easy to recognize and report, and I'm sure that if you snapped the photo when it went to an expert, people could identify it quite readily. So this is the scary slide to me. This is the distribution as of now, and it initially was found in southeastern Pennsylvania. And it was just pretty much contained to contiguous counties. The starred counties in Virginia, Delaware, and in New York were found in the fall of 2017. So that's really scary to me because it says that these insects are actually jumping across counties. So they're actually moving long distances. So I would suggest that anybody who's receiving any kind of nursery stock, any kind of shipment and such from Penn State, from the state of Pennsylvania, is more than likely to, it could indeed receive something with an egg mass on it. So keep your eyes open. This insect might be on the move quite readily. So so keep your eyes open. And if you see it, you want to report it. Okay, 2 more bugs to go. We are going to talk about the hemlock woolly adelgid, which I want to remind you next week we'll be talking about in depth when Mark Whitmore talks about it. And I'm going to review the signs and the symptoms. This you see is a hemlock over here, and on the undersides of the leaf, you'll notice these little white fluffy masses, which for me as an expert on scale insects can really see, but I think what most people are going to see you wind up seeing sickly looking hemlock trees that, and then when you look up close, then you could confirm that it was caused by the hemlock woolly adelgid. Eastern hemlock is really common in Eastern North America. There's some pockets of it in the Midwest and in the upper Midwest, but for the most part, it's an Eastern species. It's really important for the ecosystem for creating certain kinds of habitat. Trout fishermen, need these cool streams for the trout and such. But it's been around for a long period of time. Hemlocks can live for 800 years, and so losing it can be a real big deal. Here we see some hemlocks that have been killed by the hemlock woolly adelgid. You can see they're a substantial component of the forest, and their loss is quite an eyesore, and it can really disrupt the ecosystem services. So you can imagine what happens when you lose those trees, and you could change the quality of the water going into the stream and the like. These are scale-like insects. They're somewhat in between a scale insect and an aphid. They used to be called woolly aphids, but they're actually in a group called adelgids. Each female can lay up to about 300 eggs in the course of its lifetime. It came from Japan. There are 2 generations a year, and it spreads on the wind or when a bird or some other insect will be on an infested tree and carry the crawlers around. So it can be wind dispersed, or birds, or sometimes even deer that are running through a forest that can get some of the crawlers on their fur, or say a person who is doing the same sort of thing. They can actually move these things around. So hemlock woolly adelgid kills these things. Here's an electron micrograph of a female. You can see the fine platinum-like wire mouth part in the front section of the insect. That actually attaches itself to the leaf tissue, and with repeated feeding on the leaf tissue, they wind up. This is the actual leaf tissue over here. They start sucking, and they feed on the phloem and the xylem, and they will actually cause a localized chlorosis or yellowing of the leaf. And in time, the leaf loses its ability to photosynthesize. That slows down the growth of the tree, and then the tree eventually dies. This is another life stage that you might see in the springtime. So you see here, we see the leaves. Okay, so one of the things that you wanted to know is that they only feed on hemlocks. So don't worry about it on spruce. Don't worry about it on fir. So in order to be able to identify a hemlock, you have to know that there are 2 rows of needles on each side of the twig, and on the underside of each needle are 2 blue bands. Okay, so you see blue bands on the undersides of the needles over here. Okay, and so that's, these are some real diagnostic features. Young trees have smoother bark, and mature trees have thick bark with flattened ridges with an orange tint. They have got green cones that turn brown that are also somewhat diagnostic. And so look for sick hemlock trees, white filaments of wax on hemlocks, and even after the tree has died, you'll still see the waxy residue on there. Some lookalikes include spider egg masses, and you can see that you can tell that's not, because this fuzzy ball of spider egg mass is actually much bigger than, it's much wider than an individual leaf. Pine needle scale is not going to be furry, it's going to be waxy. And then spittle bugs are going to be sticky, because that's caused by an insect that blows bubbles in its own excrement on a twig. Okay, last bug, thousand cankers disease. This talk was adapted by presentation put by Christy Stoltz. And one of the things, just like with the hemlock, probably the most important thing about detecting thousand cankers disease is to be able to identify what a black walnut looks like. These are large trees with compound leaves, and I think you just remembered I spoke earlier about ash trees. I know they also have compound leaves, but the leaf shape is a little bit different. They have a lot more, black walnuts have a lot more compound leaves per leaflet. And then the other thing about it is that if you would split the chamber of a twig, it would be actually be a chambered pith, as you can see. And probably the most important thing you can see is that the branches are alternate. So you see the red diagram on the lower right-hand side of the slide. You see a branch, you see a main stem and a branch, and then you have to go down the branch, the twig, till you find another leaflet, coming out. So the leaflets are opposite, and the leaflets are alternate, and the branches are alternate. So if you see a diamond-shaped bark and alternate branches, it is going to be a black walnut. If you see diamond-shaped bark and you see opposite branches, it is going to be an ash tree. Okay, so that's really, really important, because remember I told you that story earlier about the fellow who misidentified his walnut as ash, his ash trees as walnuts, and he thought that he had thousand cankers disease because he saw a rapid decline of what he thought were black walnuts, but in fact they were actually ash trees. Okay, so what's thousand canker disease? Thousand cankers disease is a disease that requires black walnut and a fungus called Geosmithia morbida, okay, which causes localized necrosis or localized dead spots underneath the underneath the bark, and it needs a walnut twig beetle or some other insect vector that can transmit it to a new tree. All three things have to be in play. The fungus does not move on its own. It needs an insect vector. Okay, so here we see the walnut twig beetles. They are actually boring through the tissue beneath the bark, and you can see wherever they're feeding, there's this like blackened wound response, and that's actually the dead tissue. Okay, and the dead tissue is killed by the fungus, Geosmithia morbida. So one of the things that you'll notice is that these photos were taken in Colorado, and many of these pictures are here courtesy of the Colorado group, Ned Tisserat and Whitney Cranshaw, and you'll see that this happened. The trees die really fast. It's rather dry in Colorado, and you'll start noticing some flagging, as you see in the photo labeled June 2008, followed by what you see in September. You start seeing that there's more yellowed area. Then the next year, parts of the trees are entirely dead. So you can see that it progresses quite readily, and that's because these walnut twig beetles are quite numerous. I mean, look how many you can put on the head of Abraham Lincoln on a penny. This vial over here has over 20,000 beetles inside of it. Okay, and two 18-inch logs will produce that many beetles. So, each spot where the beetle goes in and feeds will cause a cut, and it's caused thousand cankers disease because there are 1,000 little cuts underneath the bark, and that transmit this fungus and causes this localized death. And when the wounds coalesce, that's when you actually kill the tree. So the best time to scout is from late June through August. Thousand cankers disease symptoms develop as with other summer stresses. So you'll start noticing these things from June through August when things tend to dry out. Okay, so here are some of the early symptoms that you'll see, followed by the later flagging, and that you see over here, and eventually death. Okay, so that's pretty much what I had to cover here. Just remember that if you want to report, you want to organize citizen scientists to report in your state, you can look up the app. There's this URL over here called apps.bugwood.org/apps. We'll give you the list of all these reporting apps that are available for different parts of the country. We use the Great Lakes Early Detection Network app because that is been modified for us for as part of our group in Indiana, and that's I hope you'll find that useful. So remember, first of all, that you'll be getting an email to complete a survey. These surveys are really important because in order for us to keep on bringing these presentations to you, we need to demonstrate that people are actually listening and they find these presentations useful. So if you do find it useful, we need to know so we can continue our funding. And if you found that it was not useful, we would like to know why, because we want to make sure that these talks that we give, that we and our colleagues put together, are both topical and useful for you. Okay, with that, I can take questions.
All right, and if everyone could just put any questions they have in the chat box, I'll read them off so that Cliff can answer them. I've also put a link to the Bugwood apps in the chat box, so you can click through to that there if you're looking for that. Okay, so Gregory is asking, is there a quarantine on nursery stock from Southeast Pennsylvania?
Is there a quarantine on nursery stock from Southeast Pennsylvania? Okay, I do not know the answer to that question, but I do know that if you talk to your state Department of Agriculture, you will. They will know that. So I know in Indiana, we would call the Indiana DNR. We would know if there's a quarantine. I would suspect that it is that because this is an exotic pest, that it is indeed regulated.
Okay, next question. Patrick asks, can we use the GLEN app in Canada?
Can use the GLEN app in Canada. I don't know. So what I would do is look at the apps at Bugwood to see if indeed that they have those apps available for Canada. And I know that if you wanted to develop an app for Canada, you would contact Charles Bargeron, and I'm sure they could put it together. You know, these apps, there's one for mid-Atlantic states. There's quite a few of them. They all run the same way, and I think a lot of it. So what really has to be done is you basically would slap your logo on the front screen, and then choose the list of pests of which you're interested in, and Google Maps and the GPS power of your smartphone moves across the Canadian border, quite easily. So this is something that could be done if there was a need. So somebody from the Canadian Forest Service or Canadian Department of Agriculture, if they're interested, I'm sure that the Bugwood people will be happy to talk to you about it.
And before I move on to the next question, Robin just wanted to let everyone know that EAB has been found in Vermont now. So it's still spreading. Okay.
Yep.
Oh, sorry, go ahead, Cliff.
No, I read about that one today, and yeah. So it's a bit of a tragedy, but hopefully some of those cities like Burlington will use some of the technology we developed in the Midwest to keep some of their trees alive, because it's a lot less expensive to keep them alive than it is to remove and replace them with something else.
Okay, so the next question is from Eric, who's asking, are there currently any known treatments for thousand cankers disease? Is there any work being performed to look at this?
Okay, there are no treatments at this point in time for thousand cankers disease, although I do know that Matt Ginzel, my colleague here at Purdue, is working in some plantations in Washington State, where they are trying some combination of trap trees and pyrethroid insecticide application. So basically, the idea is, by girdling trees and attracting uh, beetles to insecticide-treated trees, you can kill a large proportion of the vectors in a field, and that would slow the spread of the the disease through a plantation. But so research is being done on this. In terms of thousand cankers disease, Matt Ginsel gave a talk about this, I think 1 or 2 semesters ago on EAB University. You should certainly look it up. The latest thinking about thousand cankers is that east of the Mississippi, where we have a lot of rain, it's just not dry enough for the disease to manifest itself. We do have vectors. We do have the fungal agent, but the trees are too healthy to be killed by it. Geosmithia morbida is a rather weak pathogen that requires a water-stressed host in order to progress, and I think we just have too much rain. But that's not to say that we can never have thousand cankers disease. I remember in 2012 we had some historic drought where even the corn dried up and died before it was able to be harvested. So a couple of years of drought in a row, and I could easily see thousand cankers, popping back up. So I think we may have dodged a bullet for now in the east, but not permanently. In the west coast, and especially in the northwest, I think there are issues with thousand cankers disease, and certainly in the west, Colorado and the like.
Our next question is from Rachel, who asks if any climate, particularly cold weather, limits spotted lanternfly.
I do not know the answer to that question, but given that from where, it seems that some of the places of origin are indeed tropical. That is a possibility, but the parts of Pennsylvania where they are get to be quite cold. So I don't think that that's necessarily going to save us. But I don't know what it will do in Minnesota. Okay, but I'm going to guess that if it's surviving where it is in Pennsylvania, I would say most of the Midwest will be hit if it gets there.
Our next question is from Noah, who asks, where is ALB found in North America, and what is being done to prevent spread or eradication?
Okay, there is a site, you can look up Beetle Busters or Stop the Beetle. That gives you your up-to-date location as to where they are. I know that there is a spot near, so it was detected, places where it's been detected have been places like Chicago, and that is actually a really successful eradication spot. It's because it hasn't been detected since eradication efforts have been made. It's also been found in southwestern Ohio near the Cincinnati area. The infestation is still going on. It's still present in the Worcester area of Massachusetts. It's also in, there was an infestation in New Jersey, which seems to have been eradicated, but there are occasional spots in that northeastern area. So what's happening is because this beetle is so large, it's a lot easier to see and detect than the emerald ash borer. The other thing is that these beetles are kind of fat and lazy. They once they're on a tree, they're not going to fly real far if they don't have to. So they're not going to fly miles and miles. They're not going to move up to 7 kilometers. If they need to, like the emerald ash borer. So they're not spreading as fast, and because the beetle doesn't spread as fast, the policy of surveying to find the extent of an infestation and then eradicating all the hosts to essentially cauterize the wound seems to be a really successful strategy. It has not eliminated Asian longhorned beetle, but since Asian longhorned beetle and emerald ash borer were found at the same point in time, you can see how the differences in biology seem to be allowing relative success of that quarantine and eradication procedure. We have not lost, we have lost hundreds of millions of ash trees already to emerald ash borer, but we've only lost tens of thousands of maple trees to the Asian longhorned beetle.
Salvador asks, will spotted lanternfly, if it spreads, be worse than EAB?
The question is, will spotted lanternfly be worse than EAB? Well, it really depends on things. There is. I know that there's some research. I was talking with Deb McCulloch just yesterday, and she was telling me that there is some research that's going on, trying to look at some of the systemics that we've been using to control control emerald ash borer. Some of the neonicotinoids are quite promising. I know they work pretty well on sucking insects, so we might have some tools that we might be able to use to manage these things. They don't kill trees outright, so I don't think they're going to be nearly as bad. But if you are a grape grower and you have to pick out spotted lanternflies out of your bunches of grapes, or if you are an apple grower and this is starting to harm the health of your tree, it could be really, really problematic.
All right, I don't see any more questions right now. Does anyone else have anything they'd like to ask? Okay, I will give it back to you then, Cliff.
Okay. Well, listen, once again, I want to thank you all for taking the time to be with us this week. And remember, next week we have Mark Whitmore of Cornell University, who'll be talking about hemlock woolly adelgid, and he'll also be talking about biological control efforts in New York State. Okay. Well, so I guess we'll sign off, and thank you very much.